Okay. Linear workflow. Confusing. Let's change that. Linear workflow is used in compositing when working with passes, for example. As explained in my Octane passes tutorial, passes are used to get greater control over your graphics, better integrate CG elements into live footage, and achieve better realism in general. This video is about how to use passes properly and bring your compositing game to the next level. Today I will show you how to properly work in Fusion, After Effects and Photoshop. Before we jump into fun part, let's understand why you need linear workflow after all and what are the benefits. All devices in the world output stuff pretty much in the same way. But in order to do so, they apply sort of filters on everything. They are correcting gamma of everything that's been fit to it. sRGB gamma curve looks like this. Whenever you're viewing something, our devices are applying correction to this curve and displays colors properly without you even thinking about it. And linear gamma curve looks like this. But whenever you're trying to preview a linear image, your monitor thinks it's sRGB content and tries to display it as sRGB. That's why linear images may look very wrong on your screen. Linear workflow is the workflow that allows you to bypass all that filtering stuff and compose and output your content correctly. Any CG or VFX or motion graphics activity involves stacking images on top of each other. It may be adding a smoke on your footage or fire, or working with multipasses. Anyways, images are stacked on top of each other, meaning color values are added on top of each other. It's easier to explain it visually on a practical example. This is our sample for today. Regular sRGB image. So let's drag it to After Effects, create a new comp, and here it is, just regular 8-bit sRGB image. Let's try to add fire on top of it. So usually you would use add blending mode, right? But see what happens. The clipping occurs in the highlights, and it doesn't look nice. It might not be the perfect example, but you know, it's good to show the difference of what I'm talking about today. You could try linear dodge mode, which is a proper overlay mode to use while compositing, but same clipping happens. You may want to use screen and it works alright, there is no clipping, but it's so dull and washed out. Let's click here on 8-bit channel and switch it to 32 bits and linearize working space. Check this out. Now fire is applied in a much more pleasing way. And as you can see, the difference between sRGB workflow and linear workflow is very big. You have punchy colors from your fire. In 32 bits linear workflow, you have enough space for all the values to be stacked together. Without overthinking, that's all you need to know. We won't go deep into how values are added to each other in sRGB and linear workflow. All you need to know is why you need it, what's the benefits and what's the difference and how to do it. But this was a pretty basic compositing example. Now let's try multipasses. My example was made in Cinema 4D and rendered with Octane. In order to properly set up linear render, you will have to look up some tutorials about the engine and software you use. I will quickly show you the crucial settings in Octane for Cinema 4D. The first thing you want to do is to assign a camera tag to your camera, obviously, and go to a camera imager, enable it. The most important setting here is neutral response. Response here, where you have a big drop down with different options like looks, is not important at all. Okay, that's done. Go to main settings, so render passes, enable them, specify where you want to output your passes, Format, choose EXR because it's the most appropriate format for multipass workflow. If you want to know more, again, check out my Octane passes tutorial. By default, depth would be set to 16-bit, but we want 32. Leave compression at whatever it's set to. Save beauty because it will be your reference to compare to, and image color profile and tone map type would be set to linear by default. Then choose whatever passes you need to render, set everything up there, go to your main tab, and this is the most crucial thing to select. Render buffer time. By default it would be set to float tone mapped, but you need float linear. And this is the only setting that actually is responsible for whether your output will be linear or not. Neutral response in your camera tag and buffer type set to linear. Settings here doesn't matter at all really. You can set up JPEG, that's what I'm doing because it's irrelevant, you won't use it. Your final image will be composed result from passes. Okay, so all set, hit render. Boom, render done. Now let's open After Effects. So here is your EXR file. Drop it in After Effects, create the new comp, and voila, just a black screen because it doesn't know what to show. Since some time ago, After Effects has a dedicated tool to extract multipasses from EXR files, and this is super great because you don't have to download any third-party plugins. In Effects and Presets tab, type in EXR, you would think, but no, EXtractor. Drop it on your pass, and boom, it's black again. Because you need to click here. The most convenient passes selection pop-up in the world. You can choose whatever pass you need. Let's choose Denoised Beauty because it will be our reference. And here's what I meant. It's displayed incorrectly because After Effects treats it as sRGB content. And in order to fix that, we need to say, hey, After Effects, this is a linear image. Show it appropriately, please. Click on 8-bit thingy here. Change your depth to 32 bits per channel because that's what we rendered in. Working space would be sRGB, but check linearize working space. Click OK. Ta-da! Let's compare it to Cinema 4D render. Huh? Looks similar? Similar, yeah. Done, simple as that. After that, you can start placing your passes on top of each other. Let's call this beauty reference. Duplicate it, click again, choose. One thing I like about this extractor thing is that it places all the passes in order from top to down. This is how you need to place your passes. So diffuse direct would go first. Rename it for convenience, diffuse direct, and then do the same with other passes. Once done, it's good to remember the order of passes. Diffuse direct, diffuse indirect, emission, reflection direct, reflection indirect, then light passes if you have any, and then post. Select all the passes except the first one, which is diffuse direct. And in blending mode, choose linear dodge. Remember I told you that's the mode to use when comping. And here you go, you have the same image. Compare them, drag this one on top of others. Our composed thing looks brighter just because it has post pass on top. And beauty reference doesn't. That's it, here you have it. Now you can do fancy stuff like controlling post pass separately, control your reflections separately, and then overall, after all work done, all your projects or all your images will look much more realistic because you have a much more precise control over separate elements. If you would try to add fire on top of this one, it would be the same as with our first example, and all elements would be added correctly. If out of interest you would change it back to 8-bit, non-linear space, it would look like a turd, so don't do that. Work linearly always. Look at that, that fire is added beautifully to this image. An info panel in upper right corner, you see that the values can go even higher than 1. But this is something, from that fancy explanation that I wanted to avoid without all the numbers and math behind the scenes. Now let's see how to do it in Photoshop. Photoshop by itself is not as cool as After Effects. It doesn't know what EXR files are. So you would need to download a third-party thingy called EXR.io, link in the description by the way. Install it, and next time you would open EXR file, it would recognize it and offer you some options. Split alpha, blah blah blah. Just leave it like that and open it. All our passes as layers. Just remove those unnecessary alphas here. I think it's handy dandy with other types of scenes where you actually have alpha, but not in this one. Disable these layers, they're useless for us. A good thing about EXR.io is that it actually sets all the Photoshop color settings for you, so you don't need to tell Photoshop that, hey Photoshop, show this correctly. It does it for you. See, right here, RGB 32 bits. Not so good thing about EXR.io is that it doesn't place your passes, so you would need to reorganize them manually, like that. And same as After Effects, select all the layers above the main one, select linear dodge as your overlay mode, and here you go. Compare it to our original render. Yep, here it is. And now you can do the same things as in After Effects. Correct this blown out screen, for example. Increase post-pass influence. See how much information does 32-bit image contain. The reason I showed Photoshop, because, not all of us are doing motion images. Okay, and finally, Fusion. Fusion needs third-party script to extract EXR passes, unless you wish to do it manually as I used to do. Here is the must-have add-on for Fusion. It's called Reactor, and it's like a library of all useful scripts for Fusion. Link is in the video description. Installation is pretty straightforward. You just download the archive, drop the Lua file into your console and follow the steps to install Reactor. Once Fusion restarts, you can now select the scripts you want to install. We need this one called Split EXR Ultra. So load your EXR pass, click script, Split EXR, okay. Here are all our passes. And if I will display any of them, they are super dark. Because same as After Effects, Fusion doesn't know how to show this stuff. This is our beauty, leave it as reference. And even worse, unlike After Effects pop-up menu, Fusion plays the passes just randomly wherever it wants. That pisses me off, of course, but that's what we do. So remember, diffuse direct, diffuse indirect, emissions, reflections direct, reflections indirect, then volumes or whatever there is in your passes, and all the other stuff, including post-pass. Once everything in order, you can start merging these nodes together by just dragging this red square to this red square, which means you are applying second pass on top of the first one. Okay, just do it for all others. In Fusion, the analog of linear dodge overlay mode is this setting in your merge node. Burn in and slide it all the way to the right. So there are two steps you need to remember about. First one, you would need to add a node after all your manipulations and stacking and whatever it is you're doing in order to output your content properly. And the second thing is you would need to use LUT in your viewer in order to view the content properly. Control space, type in gamut and place it in the end of my chain. In the gamut, you see we have source space and output space. We don't need to change source space, but we want to change output space to sRGB. So the left window is now showing correct result in sRGB using this node. Right viewer, we will use LUT on it. Click here, LUT, select gamut view, select edit, and do the same, output space sRGB. So again, the left one is showing the node that is converting our whole chain into sRGB and makes it ready for output. The right viewer shows our linear content, but with LUT applied on top. And it's a really important difference if you would compose and using the LUT in the viewer and then export without the gamut node, you would export all linearly and everything would be dark. After the chain, you add saver node, tell Fusion where to save your image. Okay, so this is all good, all cool, and this workflow will be used in 99% of your work, but there is something else very interesting I would like to talk about. And this thing I'll talk about is exclusive for Octane, so if you're not Octane user, then thank you for watching, I'll see you next time. But if you are, keep watching. I rendered another version of this shot, absolutely same, but this time I added some light passes as well. So I will just bring it in, have a look here. See what happens? The weird and absolutely unbeautiful clipping occurs. If you would check our previous version, it's absolutely fine, but here the highlights are blown out and this all looks terrible. This happens because of one simple reason. Octane does not exclude light from diffuse channels when you're using lights in a separate passes, and that's weird. I don't remember that happening in any other render engine. Usually if you're rendering light passes separately, then it should be excluded from all other passes, because what's the bloody point of separating the light if it's still in other passes? I will use this video as a bridge to another tutorial I'm working on, and it is about ACES workflow. ACES workflow is basically a linear workflow alternative in video color grading. But I found it really helpful in some specific situations when comping CG stuff. Let me show you what I mean. I will talk about all that ACES workflow in the next tutorial, but just to quickly show you. You remember problems we had, and using ACES workspace, this is the result with it. With all the passes applied on top of other passes, we have perfectly, I would say, a linear image that we can keep working on. So on the left, it's just regular linear image with light passes. On the right, it's ACES workflow. Cool, isn't it? I hope you feel intrigued. I know what you're thinking, Andre, you're like appearing once in half a year. I'm still busy, but I'm working on it. My new interior, that's the proof of my dedication to this channel. ACES workflow next. See you then. Peace.